Hello everyone and welcome to Storytime. Miss Kara is not feeling well today, so I'm filling in. Today we're celebrating Katherine Johnson for Women's History Month. She lived from 1918 to 2020. She worked at NASA on calculations for spaceflight, including the flights of Alan Shepard, who was the first American in space, John Glenn, who was the first American in orbit, and on several of the flights to the moon. She was awarded the Presidential Medal of Freedom in 2015 for her contributions to NASA. She was one of the women at the center of the movie Hidden Figures, which is about women of color who worked for NASA in the early days of the space race. She was extremely accurate in math calculations by hand, and she also helped pioneer the use of computers. And that's a picture of her. It was taken in the 1980s. You can read more about her either online or through some of our books in the library. To celebrate her accomplishments today, we are going to read this book, which is called Kids Get Coding. It's about coding, bugs, and fixes. It's by Heather Lyons and Elizabeth Tweedale. It has a lot of new vocabulary, but the more you hear it, the more sense it will make. And this will explain some of those things. Kids Get Coding. Coding, Bugs, and Fixes. It's by Heather Lyons and Elizabeth Tweedale, and it's illustrated by Alex Westgate. A lot of books that are nonfiction, and that means that books that are about real things, have something called a table of contents. And this tells you what information is on what page, so you can move ahead or backward or find the information you want. Getting started. Hi, I'm DataDuck. Oh look, there's DataDuck. And I'm here to help you learn all about algorithms and bugs. We're going to have lots of fun with activities too. An algorithm is a simple set of instructions that tells a computer what to do. We're going to learn how to make algorithms, how to try them out, and how to fix them. And DataDuck says, here are some terms that you will learn about in this book. Try saying them out loud. Ooh, these are fancy words, but I bet we can learn them. Algorithm, sequence, code, loop, and debug. Cool. Oh, there's a note here at the bottom. There are lots of activities in the book for you to try out. There are also some online activities for you to practice with too. For the online activities, go to www.blueshiftcoding.com/kidsgetcoding and look for the activity with the page numbers from the book. So that could be a fun thing to try. This one's titled Computers Everywhere. Computers are all around us and come in all shapes and sizes. We can use computers to help us do things, such as make phone calls, pay for groceries, and do homework. Computers are machines, so they aren't very smart on their own. They need instructions to be able to do their tasks. This book will teach you about how to give computers instructions. See, there's a truck that's got a computer logo on it. There's a tablet. DataDuck says a computer's instructions are stored in its memory. What can you see? Can you spot 5 different types of computers on these pages? What is each one used for? Oh, cool. We saw a tablet here. What other computers do you see? I see a phone, and that looks like an all-in-one computer. Maybe that's a smart TV. And that radio probably has some computer parts in it too. What is an algorithm? Algorithm sounds like a big word, but it just means a series of steps like those of a recipe. Computers use algorithms to complete all the tasks we need them to do. We have to give computers clear instructions in the algorithms so they understand what to do. Oh, there's an algorithm here. Dataduck says, a computer will use an algorithm to play a movie, search the internet, or make a phone call. I wonder how it does that. We use algorithms to do all sorts of everyday jobs. An algorithm for brushing our teeth might look something like this. Number 1, take the lid off the toothpaste. 2, pick up toothbrush. 3, wet toothbrush. 4, put a pea-sized drop of toothpaste on the toothbrush. 5, brush top and bottom teeth for 2 minutes. 6, spit out toothpaste. 7, rinse toothbrush. 8, put toothbrush back in holder. 9, put lid on toothpaste. That is a sensible way to brush your teeth. I think, though, that I do some of these in different steps. I wonder if I were to write this, I think I'd do it differently. How would you do yours? Oh, here's a Post-it note here. It's called Write an Algorithm. Try and write an algorithm for getting ready for school. You'll need to think about all the things you do from the time you wake up to the time you leave your house. On the toothbrush example, I think I would put the lid back on the toothpaste right after I put the pea-sized drop. But otherwise, I think it's about in the same order. Gosh, there are a lot of steps for getting ready for school. I think that could be more complicated than brushing my teeth. Order. The steps of an algorithm need to be in the correct order for it to work. The order of steps in an algorithm is called a sequence. When we write an algorithm, we have to get the sequence of steps right. When we get dressed, for example, it would be silly if we were to put our shoes on before our socks. Oh, that would be silly. Dataduck. The steps of an algorithm are in the wrong order. The algorithm won't work. Yep, that doesn't work very well. Cookie algorithm. Dataduck has written an algorithm to help him make his favorite chocolate chip cookies, but he's got the order of the steps all mixed up. Can you put the steps in the correct order? Let's see, what does he think? Mix together the butter and sugar, then add eggs and flour. Turn the oven off. Put spoonfuls of mixture onto the tray, then bake for 10 minutes. Grease the baking tray. Eat and enjoy. Heat oven to correct temperature. Those are mixed up. I think if I were baking cookies, I'd do this one first and this one second. What would you guys do? Well, that's an activity that you guys could do if you wanted to check out this book. Let's see what else it's got going on. Make a move. Algorithms are written in code. This is a kind of language that computers can understand. When we animate a character on a computer, we use code in the algorithm. It tells the computer where the character should be on the screen. To make the character move, we need to change the character's position over and over again. Like this one. Move 10 steps, whoop, move 10 steps, whoop, move 10 steps, whoop, move 10 steps, whoop, move 10 steps. And the character moves across the page. Dataduck says, the things that we can change in the algorithm, such as size, color, and position, are called variables. That's another big word, but it just means things we can change. If we want to change a character's size, color, or position, we have to change the code. These have several changes. The color of the shirt of these characters is different. The shape of the kite is different, and the color of the kite is different. But some things are the same. The kites all have the same pattern. The string all has the same shape. And the character here looks like it's all the same pattern too, just the shirt color is different. Spot the variables. Look closely at the two pictures below. Can you find 4 different variables in the second picture? Use this list to help you. Position, size, costume, rotation, and movement. Oh. Let's see here. The duck and the mouse are in different positions. The duck has a different costume in this picture. The mouse has a different rotation. Let's see. The size could be different, but it's hard to tell here. Oh, well, yes, I think the mouse is bigger in this one. Cool, I think we found them. Loop the loop. Sometimes we need computers to do a task over and over again. We call these sorts of instructions loops. We repeat tasks every day. When we walk to school, we repeatedly put one foot in front of the other. When we pedal our bikes, we move our feet round and round. To tell a computer to do these things, we can use loops. On page 10, we had to tell the duck to move 10 steps 5 times to get to move across the page. Another way to do this is to put one instruction inside a loop, like below. Repeat 4 times, move 10 steps. So he loops, move 10 steps, loop, move 10 steps, loop, move 10 steps, loop, move 10 steps, loop, and then he's done. DataDuck says we use loops whenever there's an action or instruction we want to repeat. For example, I need a loop to be able to walk all the way across the screen. Jam sandwiches. Imagine you're working in a sandwich shop and need to make the same type of sandwich over and over again. Write instructions to make a jam sandwich. If you had to make 10 jam sandwiches, which steps would you put inside your loop? Oh, that's a good question. I think you'd only have to open the jar once, but you'd have to get the bread out several times. You'd have to spread the jam several times too. And maybe press the slices together. I think that could take several sets of loops. I think it would be easier to make a jam sandwich than try to write out the instructions for the jam sandwich. What do you think? Predict it. It's helpful if we can predict what an algorithm is meant to do before asking the computer to complete the instruction. When we press play, I mixed those up, didn't I? When we press play on a video, for example, we expect a movie to start. But if the steps are in the wrong order, the video won't play. Look at the algorithms below. Can we predict what will happen to DataDuck if we give him the following instructions? Change size by 1/10 smaller. Rotate by 1/4 turn. He's going to become smaller and twist around by 1/4 turn. Now, can we predict what will happen if we change the algorithm again? He'll make the same movement at first, but 4 times. He's going to get smaller 4 times, and turn 4/4 turns. There he is, getting smaller and turning a 1/4 turn each time. And there's the loop. Repeat 4 times. Change size by 1/10 smaller. Rotate by 1/4 turn. Guess the shape. Can you predict what shape DataDuck is drawing? Ooh, this sounds like a hard one. Repeat 4 times. Move 4 steps. Make 1/4 turn. Now, try writing your own instructions. If I were DataDuck and I were moving 4 steps, 1, 2, 3, 4, and then taking a 1/4 turn, 1, 2, 3, 4, and another 1/4 turn, 1, 2, 3, 4, and another 1/4 turn, 1, 2, 3, 4. I think I might end up with, what kind of shape do you think that is? Try Try it yourself and see if you get the same answer I did. Now try writing your own instructions for a cross shape, a T shape, an L shape. Can a friend guess the shape by following your instructions? Decisions, decisions. Sometimes computers need to do something only when a special condition is met. To do this, they use if statements to make decisions. For example, if we tell DataDuck to move to the right, we want to make sure that he doesn't move off the page. So, the computer needs to make a decision about what DataDuck should wear today. First, it will check the weather. Then it will look at a series of if statements to decide what to do. Oh, I think we missed this. Let's see here. So this is supposed to keep DataDuck from falling off a page. Repeat 5 times. Move 10 steps. If on edge of page, reverse direction. So let's try the if statements for what DataDuck will decide to do. If it is sunny, tell DataDuck to wear sunglasses. If it is raining, tell DataDuck to bring an umbrella. If it is snowing, tell DataDuck to wear a winter hat. DataDuck says, here's how to make an if statement. First, think of a question you'd like to ask your friend. For example, is it raining? If the answer is yes, they will have to do the following. Bring an umbrella. So the statement is, if it is raining, bring an umbrella. So let's make a statement. Let's make an if statement game to play with your friends. Write 3 different if statements on separate pieces of paper. Put them all into a hat. Shake them around and then take turns to be the caller. Each caller reads out an if statement for you and your friends to follow. For example, you could use the following statements. If you are a girl, raise your hands in the air. If you have brown hair, stand on 1 foot. If you are a boy, touch your toes. It could be anything. If you are hungry, raise your hand. If you are not hungry, spin around. Let's do one more. Search and sort. Algorithms can also be used to help search for information and sort through it. For example, a computer can put names in alphabetical order. The computer uses the alphabet to compare letters to see if they come before or after other letters. There's DataDuck. He says, algorithms that sort information have 2 simple parts. 1, data to be sorted, and 2, a rule for sorting the data. Friend sorting. Can you sort your friends by using a simple rule? Oh, sorting your friends is a dangerous thing. Let's see how this goes. Follow these easy steps to search and sort out information about your friends, just like a computer. 1. Write down the names of 8 of your friends. 2. Cut up the names and put them in an envelope. 3. Pull them out 1 name at a time and put them in alphabetical order. Aha, so you're sorting them by the letters that their names start with. Can you think of other ways you might order your friends? For example, would you sort by height or by age? These are in height order. You could also sort them by maybe other things, but I think it's also good to apply sorting to marbles or to playing cards. I remember I used to put playing cards in order all the time. Let's do just one more. Catching the bug. Algorithms are very useful, but sometimes they don't work, and we need to find out why. Problems with algorithms are called bugs. When a programmer reads through an algorithm to find errors and fix them, it is called debugging. Errors might be that a step is missing or that a part of the sequence is in the wrong order. DataDuck says, when computers were first invented, they were enormous. One day, one of these big computers wouldn't work. When the scientists took it apart, they found a moth inside. Some people say that this is why we use the word computer bug. Ooh, bed bugs. Have a look at this algorithm for getting ready for bed. There are 2 bugs in this algorithm. Can you find them? Put on pajamas. Brush teeth. Put on pajamas. Whoop, I think I found one. Get into bed. Turn off lights. Read story. Go to sleep. I think it could be, depending on where you live, this could be the second one, because it could be hard to turn off the light after you get into bed if the light switch is too far away. So we don't know. I guess we would have to go to the end to find out. Well, I hope you've enjoyed reading with us about coding today and learning a little bit about the legacy of Katherine Johnson. Thanks very much and have a great day. Bye, everybody.